can do this sort of thing and accomplish it. So quadratic functions. So quadratic functions, we're going to deal with two different forms in our lesson tonight. The first form we're going to deal with is standard form. Standard form, f of x equals ax squared plus bx plus c. The form we just saw in labs, the only difference is we're not equal to 0 at this point. We just have a function, it's y equals or f of x equals, whichever way they want to write it, it's the same thing. And we know that that creates a parabola as a graph. Okay, so I'm just going to draw a generic one over here. Don't have to have graph paper for this because it's not going to be, super precise. So I've got the x and y coordinate plane, and I'm going to draw a parabola on there. So I'm just going to draw one that, goes like that. Okay. So you've got several key pieces to this graph. One key piece is the y-intercept. Another key piece is this point down here at the bottom. That's called the vertex. Okay, so that's a very important point. And then two other very important points are the x-intercepts. So where it crosses the x-axis. So all of those are key pieces to the graph of that. There is one other key piece of the graph that isn't drawn on there yet. That key piece of the graph that I'm talking about is the axis of symmetry, which is this imaginary line that goes down through there. That is called the axis of symmetry. The axis of symmetry, if we folded that parabola along that axis, then it would match up perfectly on each side. That's what a parabola is, symmetric. Notice how that axis of symmetry goes right down through the vertex every time. It always does that. And we're about to see the math that makes that happen. Okay, so the key features that we're talking about with a quadratic are the axis of symmetry, the vertex, whether that vertex is a maximum or a minimum. We'll talk about what makes that happen. And then the intercepts, the y-intercept and the x-intercepts. Those are our key features. So it's like 5 things out of there. So if you're in standard form, the axis of symmetry the formula for that is negative b divided by 2a. X equals negative b divided by 2a. It's x equals a number there because it's a vertical line. That negative b divided by 2a is the a and the b from the quadratic equation up there. Just like what we had done with quadratic formula in the lab tonight, this is part of it. Okay, so the negative b over 2a is the axis of symmetry. Now, the nice thing about that is that the vertex is an ordered pair. The x value of the vertex, I don't know why I wrote that line so long. The x value of the vertex is the same number as the axis of symmetry. So when you find the axis of symmetry, you find half of the vertex with it. Okay, so it's negative b over 2a is the x value of the vertex. It's also the same value as the axis of symmetry. So you get kind of 2 birds with 1 stone kind of situation happening there. Now, to get the y value of the vertex, you're going to plug in negative b over 2a into the equation. So that's what this means. This is plug in for x. That's the f for the function notation. F of negative b over 2a. So you're plugging in negative b over 2a in the place of x and working that out. That'll get you the y value of the vertex. Okay. We're going to do examples with numbers in there too, but we need these formulas to be able to do that. Okay. Now, that vertex can be a maximum or a minimum depending on which way the parabola opens. Okay? That vertex can be a maximum if A is less than 0. And if it's less than 0, that means it's negative. And it means that the parabola opens down. So it would look something like that. That's a parabola that opens down. The vertex would be a maximum if the parabola opens down. And you can decide if the parabola opens down by just looking at the number that's in front of x squared. That's what A is. If A is negative, I know the parabola opens down. Okay, going to have a highest point. That makes it a maximum. Then that vertex can be a minimum if A is greater than 0 or it's positive. And that means that it opens up. So the parabola looks like the one that we drew just a second ago. So the axis of symmetry, that's that negative b over 2a. That's the line that goes through the middle. The x value of the vertex is the same number. And then we plug that in for x and get the y value of the vertex. And then we can decide if the vertex is a maximum or a minimum based on what a is. If a is negative, it's a maximum. If a is positive, it's a minimum. A maximum means it's the highest point on the graph. Minimum means it's the lowest point on the graph. Okay. All right, so that gets us the axis of symmetry, the vertex, maximum or minimum, and then we're going to get the intercepts. So we're going to get the y-intercept. So to find the y-intercept on any equation that you have, we're going to plug in 0 for x. That's what that means. So this is plug in 0 for x. To find the x-intercepts, or intercept, sometimes it's single, sometimes it's 1, sometimes it's none. You're going to take ax squared plus bx plus c and set it equal to 0. So you're going to take the equation and set it equal to 0, which is exactly what we did in lab tonight. And you can either solve that by factoring or by quadratic formula. Either way gets you the same answers. Sometimes factoring is not an option, and quadratic formula is the only thing that you can do. But if it will factor, it'll also use quadratic formula. That would get the same answers. So, all right. So let's take an example that's got numbers in it and do all of these things. Find all of these fancy things. We're going to use the formulas, and then we're going to use I'm going to show you how the calculator can also help you. Okay. All right. Now, example A. Find all the key features of f of x equals x squared plus 6x plus 8. So we're going to see all those key features with this problem. I'm going to remind you of those formulas and stuff. So I'll kind of zoom out there so you can get all of that written down. You can see. All right, so here we have a quadratic. And we have y equals, or f of x equals x squared plus 6x plus 8. So that's A, B, and C. A is 1, B is 6, C is 8. Okay? So the first thing that I'm going to do is I'm going to graph it with my calculator, because that will help me a lot in seeing what's happening for this. So the calculator graph is really helpful for this. So I'm going to hit y equals, clear out anything else that I had, and I'm going to type in x squared plus 6x plus 8. And I'm going to hit graph. That looks kind of similar to what I drew earlier, just a little bit, a little further to the left. Okay, so we see that graph. We can see that graph. We see it's hitting the x-axis in two places. So when I find the x-intercepts, I should find two of them. We see it hitting the y-axis over there, somewhere, above 5. We'll find it. And then we see it's got a lowest point. So we can tell from the graph that this has a minimum. Now we just got to find what is that minimum there. So I'm going to show you using the formulas, and then I'll show you how the calculator can also do some stuff for you. Okay. So the first thing I'm going to find is the axis of symmetry. And the formula for axis of symmetry is x equals negative b over 2a. Okay. So I'm going to take the opposite of b, which would be negative 6, divided by 2 times a. And a in this case is 1. That's what's in front of x squared is a 1. And I'm going to work that out. Negative 6 divided by 2, negative 3. So the axis of symmetry is x equals negative 3. Okay. Then I'm going to use that to help me find the vertex. Remember on the vertex that the x value of the vertex is negative b over 2a, which is the same number as the axis of symmetry. So I know my vertex, the x value is negative 3. To find the y value, I'm going to plug that in for x. That's going to be negative 3 squared plus 6 times negative 3 plus 8. I'm going to work that out. This is me doing it by hand. That'll be 9 minus 18 plus 8, which would be negative 9 plus 8, which is negative 1. So the y value of the vertex is negative 1. Now I'm going to go to the calculator. I'm going to show you how you can find that with a couple of different ways to find that with the calculator. Okay. Since I found the axis of symmetry on the calculator, I can get it to tell me what the y value is for that particular x value. I can hit trace and then type negative 3 and hit enter, and there's my ordered pair, and it marks it on there that's as 3, negative 1. Or excuse me, negative 3, negative 1. Okay. Now, that's if I went ahead and did the work and found the axis of symmetry myself. Now, there may be a time that you may be having trouble finding the axis of symmetry, which makes it really hard to find the vertex if you don't know that number. So there is a way to get the calculator to tell you the lowest point on the graph. And the way to do that is hit second trace, and it pulls up the calculate menu. When I look at that graph, I can tell that it has a minimum. So I'm going to use the option 3 for minimum. If I pulled up a graph and it had a maximum, I'd use the maximum to find the vertex. Okay, so this is kind of a different method for finding that vertex, but it works. We're all, different roads get to Jackson, right? So we can all find different ways to do things. So I'm going to go to the minimum button. I'm going to hit enter. It asks me for a left bound and a right bound here. So I want to be to the left of that lowest point. So I'm just going to move my little cursor to the left. Doesn't matter how far, just make sure you're to the left of that. And hit enter. Then I'm going to move my little cursor over here to the right, because that's what it's asking for, is the right bound. Doesn't matter how far, just as long as it's to the right of that lowest point. Hit enter. Then on the guess, I always move back a little bit closer to the middle. Doesn't have to be perfectly in the middle. Notice how mine's not perfectly in the middle. I'm just going to hit enter. And then I get negative 3 and then 1 tenths, hundredths, thousandths, 10 thousandths, 100,000, 1 millionth there. So that's -3, right? And then there's -1. So that it found me the lowest point. It found me the vertex. That's a pretty cool little trick. So that's a different way of finding the vertex without the -b/2a. I think it's much easier to do the -b/2a first and then do trace that number. But this way also works. It's a lot more button pressing to use this way, but it does work to find that vertex. Now, I know that's a minimum because it's a lowest point, and the parabola opened up, the graph showed me that. I also know that this is a minimum because the a value in front of x squared is a +1. So if it's a positive, we know it opens up and it's got a lowest point. It has a minimum out of that. So that being a minimum is because it opens up and a is positive. That's the reason it's a minimum. We can see that on the graph. Just use your graph to help you. That graphing calculator is a nice tool. So we're trying to use it here. Now, the next thing was, so we've got axis of symmetry, vertex, maximum and minimum. So that's our three things. Now we need to find the y-intercept and the x-intercept. So I'm going to find the y-intercept first. So how do I find a y-intercept? I plug a 0 in the place of x. So I'm finding f of 0. So that's 0 squared plus 6 times 0 plus 8. So this is me doing it manually, doing the work. 0 squared is 0, plus 6 times 0 is 0. So that's 0 plus 0 plus 8, which is 8. So the y-intercept is at 0, 8. On the calculator, I can do what to get it to tell me the ordered pair when x is 0? Trace 0, enter. Boom, there's my y-intercept. And we see it hitting the y-axis there. So anytime you need a y-intercept, trace 0 gets you a y-intercept. Plugging 0 into the equation. That's what that's doing. It's just doing all the work in the background for us. Okay? So we did it by hand. We used a little technology to help us. Both ways get you the same answer. Both ways are absolutely legal. I'm not going to give you the test and say, well, you can use your calculator on number 3, but you can't on number 4. Be able to do that. Whichever way you want to do it, it's fine. Okay, so now the y-intercept's easy to find with the calculator. It's easy to find plugging in 0. The x-intercepts are a little bit more difficult. So the x-intercepts, the thing you're doing is you're setting x squared plus 6x plus 8 equal to 0. And you can either solve that by factoring, so the little x thing, or by the quadratic formula. Both ways are going to work on this one. I'm going to do it both ways and show you. Then I'm also going to show you a little trick with the calculator. Okay. So the x method of factoring, I think what multiplies to be 8 and adds to be 6? 4 times 2. So because there's a 1 in front of the x squared, I can go x plus 4, x plus 2, and then that's going to be x plus 4 equals 0, x plus 2 equals 0, and solve those. Minus 4. Yeah, I got -4 and -2, right? Okay, so that's using factoring. Let's check and make sure those are right. So I go to the calculator, and I'm going to hit trace -4. The y value is 0. That's an x-intercept. Look at where it's at on the graph. We see it hitting the x-axis right there. I'm also going to hit trace -2. Y value of 0. That means it's an x-intercept. So those are the right numbers. That's good news. That's doing it by factoring. Now I'm going to do it with the quadratic formula just to practice that because we need practice with that because we're going to have to use it at some point. So -b plus or minus the discriminant, b squared minus 4ac, all divided by 2a. So this is exactly what we did on lab 18. So I'm setting up, I got x equals -6 plus or minus. I got 6 squared minus 4 times a times c over 2 times 1. So the discriminant, 6 squared is 36, minus 32 is 4, so I have -6 plus or minus the square root of 4 over 2. And that works out to be -6 plus or minus 2 over 2. -6 plus 2 divided by 2. -6 minus 2 divided by 2. So that's -4 over 2, so that's -2. That's -8 over 2. That's -4. Same two answers, but finding it with quadratic formula instead of factoring. We need to be able to do quadratic formula because I know where we're headed in the next 2 weeks. Okay, so being able to solve a quadratic, just because we finished the quadratics test or most of the quadratic stuff on test last week, doesn't mean it's over. I mean, we're going to still use that in this week's stuff and next week's stuff. Okay, so that's why I'm trying to practice that. All right, so that's using it by hand. That's doing it by hand. We verified it with the calculator. I want to show you how you can find the x-intercepts using the calculator if you're stuck. Okay, so the same way I found the vertex, I can use that same menu, second trace, to find the zeros. The zeros are the same thing as x-intercepts for any problem. Zeros are x-intercepts. X-intercepts are zeros. If it uses the word roots, zeros, x-intercepts, all the same thing. Okay? So I'm going to go to option 2 for a 0. Okay? And there's 2 of them to find. So it wants a left bound. So I'm going to go to the left of the one furthest to the left. I'm to the left of it. Doesn't have to be too far. Just make sure you're to the left of it. Hit enter. And then a right bound. I'm going to go to the right of it. But I don't want to go too far on this one because I don't want to cross the other spot where it hits the x-axis. So I want to stop down there close to the vertex. Hit enter. And then on the guess, I just move back a little bit to the middle and hit enter. -4, 0. That's a 0 of that's the x-intercept. So using the calculator, we could find that x-intercept. I'm going to find the other one. Using the same tool, I'm going to hit second trace, go to 0. Then for the left bound, I'm going to be below the x-axis, hit enter. Then I'm going to go to the right of where it crossed the x-axis and hit enter. I'm going to move back a little bit closer to the middle, hit enter. And there it is, -2, 0. The same ones we found by doing it by hand, but we got a technology to help us a little bit. Okay. Typically, I use the algebra to do this, but I want to show, hey, the calculator can be your friend and help you out a lot. Okay. All right, so standard form, got to be able to find all those parts. Okay. Standard form, that's the ax squared plus bx plus c. Finding all those parts out of that. Okay. All right. Let's talk about the second form that we're going to deal with tonight, and that is called vertex form. Okay. So vertex form. F of x equals a parentheses x minus h squared plus k. All right. Vertex form is named that because the vertex is really easy to find from this form. It is actually written in there. Okay. So we're going to find the same 5 features from vertex form as we did in standard form. So we're going to do the same work. but it's going to take us a little bit different route to get there, okay? So we're going to still find the axis of symmetry. The cool thing about vertex form is I don't have to do a formula. All I got to be able to do is pull that number out of the parentheses, that h. It's x equals h. I don't have to do anything else. That is my axis of symmetry. My vertex is the ordered pair HK. So swap the sign here. H is the x value of vertex. It's also the value of your axis of symmetry. The number that's out here on the side, that's going to be the y value of your vertex. Okay. Now, the rules about maximum or minimum are exactly the same. That A that's in front does the same thing. If A is less than 0, we have a maximum. If A is greater than 0, we have a minimum. So A does the same thing in vertex form as it did in standard form. Okay. Now the y-intercept, how did we find the y-intercept in standard form? We plugged in 0 for x, didn't we? And for the y-intercept, we're going to plug in 0 for x. Work it out. Okay. Same thing. It's just we just got to follow order of operations out of that. We'll do an example with numbers in it in just a second. Okay. For the x-intercepts, we're going to set it equal to 0. So ax minus h squared plus k equals 0. And we're going to solve by square roots. And I'll show you this with our example, how it works out. It's kind of nice. Pretty cool thing. Okay. And that gets you all 5 of the key features. We can verify all of those with the calculator. We can still use the tools from the calculator to find those things as well. So we're going to go back through all of those things again with our example that's got numbers in it. Okay. So I want to speed past you here. Example B, I'm going to write the equation down here. So f of x is equal to -2 parentheses x plus 5 squared plus 2. Okay. That is our equation in vertex form. Now, just like I did on example A, my first thing I'm going to do is graph it with the calculator, because that's going to help me a whole lot to see everything happening. Calculator, y equals -2 parentheses x plus 5, close the parentheses, squared plus 2. All right. Parabola opens down. A's negative. That makes sense. Hits the x-axis in 2 places. That's good news. Does it hit the y-axis? Not on the picture here, but would it eventually? Yeah, it's going to way down here probably somewhere. It's off the screen, but yeah, it's going to run into the y-axis eventually. So we're going to still find a y-intercept out of that. So you should always on a parabola have a y-intercept. You won't necessarily always have x-intercepts, but you definitely could have should have a y-intercept always. Okay. All right. Now let's go through the finding all of these pieces. So the axis of symmetry. So I'm going to write underneath here, I'm going to write the formula for the vertex form. Notice how the formula has a -h in it. Okay, so that's the opposite sign of that. So that's going to make a difference in our numbers. Okay. So the axis of symmetry, that's what I'm finding first. The formula is x equals h. In our case, h is going to be -5. It's the opposite of the number inside of the parentheses. So it's a +5 in there. We're going to take the opposite and make it a -5. Always on the vertex form, you want to take the opposite of what's in parentheses. And it's because of this minus sign inside of the vertex form. It's the opposite sign. So the reason being that would be x minus -5. That's what is the cause of that. So our axis of symmetry is at -5. That means our vertex is -5. And then what's k? 2. Boom. And remember the vertex is h comma k. So our vertex is -5, 2. And because a is -2, we know that that is a maximum. We saw that on the graph. I'm going to verify this using the calculator, just like we did on example A. So I'm going to hit second trace. And then this one has a maximum, so I'm going to go to the maximum tool. Hit enter. Now the left bound, I'm going to have to move a pretty good ways here because it was way over there at 0. So here I'm going to move till I get to the left of the top of the peak there. Hit enter. The right bound, I'm going to move over to the right of the peak. Hit enter. I'm just going to move back somewhere close to the middle. Hit enter. And there is my -5, +2. That's my vertex. Now, why is that got that there? That the algorithm that the calculator uses there's a little bit of a rounding error that's in there. Well, I won't say it's an error. It's a limitation in the memory of the calculator is what it ends up being there. So sometimes it doesn't have that. Sometimes it does. In this case, it did both times. Kind of bad luck out of that. Okay. All right. Now, let's find those other pieces. Let's find the y-intercept. How do I find a y-intercept? Yeah. Let's plug a 0 in the place of x. And my h is, no, that's a +5 in there. So let me get that written. Squared and then +2. So order of operations says you do the parentheses first. So that's -2 times 5 squared +2. And then after parentheses, it's exponents. So I'm going to square the 5. So that's -2 times 25. And then that's going to be -50 plus 2. So the y-intercept ends up being 0, -48. Plugging in the 0 for x and just working it out. That's what we did in the standard form. We're doing the same thing in our vertex form here. Just works a little bit different because you got the exponent and the parentheses and stuff to get there. But the math's not any more difficult, I don't think. Now, I'm going to verify that with the calculator just to make sure. So on the calculator, I'm going to hit trace 0. 0, -48. I did the math right. Make sure. Just making sure. Okay. Now, x-intercepts. X-intercepts are always more difficult than y-intercepts. No matter what kind of equations you're dealing with, they always are. So I'm going to take the equation, -2, x plus 5 squared plus 2, and I'm setting it equal to 0. That's how you find x-intercepts. And we're going to solve this manually, and then we'll verify these with the calculator. So first step, if I'm going to solve this by square roots, is I'm going to get the things that are not in the parentheses over to the other side. I want to get that parenthesis by itself. That's what I want to do. So I'm going to move this 2 by subtraction. So that's going to be negative 2 parentheses x plus 5 squared is equal to negative 2. Okay, so I just moved that 2 that wasn't even attached to the parentheses at all, moved it over here. And now I'm going to get rid of this negative 2 that's in the front by division. I'm going to divide by that negative 2. That's x plus 5 squared. Negative 2 divided by negative 2 is positive 1. Okay. Now that gets my parentheses that's squared by itself. And this is where the square root comes in. So we want to get rid of that squared so that we get the x plus 5 by itself. So to get rid of a squared, we're going to take the square root of both sides. On the number side there, I'm going to put plus or minus. Because what squared is positive 1? It could be positive 1 times positive 1, but it also could be negative 1 times negative 1. So that's why we got to put that plus or minus in front of that. And then I'm going to work out that square root if it can be worked out. In this one, it can. So that's going to be plus or minus 1. On the left-hand side, it gets rid of the squared, and all I got left is the stuff that was inside there, x plus 5. So now I have 2 equations to work here. I have x plus 5 equal to positive 1. And I have x plus 5 equal to negative 1. And I'm going to try to get those to have x by themselves. Take your steps. Subtract 5. There's negative 4. Subtract 5. That one's negative 6. That's me solving by square roots there, which is the most efficient method for solving a vertex form equation for the x-intercepts. There's other ways, but that's probably the most efficient way of doing that. Now, I want to verify that with the calculator. Does that match up to where it's crossing the x-axis when we graphed it? I think it does. I'm going to hit trace, negative 6. There's that one. Then I'm going to hit trace, negative 4. There's that one. It's the same 2. That's good news. That means we did it right. Okay? So that's using the calculator to verify. What if we were stuck and we just needed to find them? We really couldn't remember how to get started. Well, I can hit second trace and go to 0. And then on the left bound, I'm going to be below the x-axis. On the right bound, I want to be above the x-axis. Go back toward the middle. There's my negative 6, 0. I can hit second trace, 0. On the second one, I want to be above the x-axis for the left bound. For the right bound, I want to be below the x-axis. Enter. Go back toward the middle. And there's my 0 of the negative 4, 0. So different ways of finding those zeros or those x-intercepts, so those roots, they're all the same thing. Anything that's important in a society or in a subject has more than one name. Zeros, roots, solutions, x-intercepts, all of those are the same name for the same thing. So that's a pretty important concept. So that's something we're going to use a lot. We're going to use it some more this week and next week out of that. Okay. So standard form, vertex form. Being able to find those pieces from that. That's the steps every single time. No matter what the numbers are, that's the steps. Okay? So let's work toward getting between the 2 different forms. So one of the other things in this section is being able to rewrite an equation in the other form. Okay? So example C is write f of x equals negative 3 x minus 2 squared plus 5 into standard form. Okay. And just a reminder, standard form, f of x equals ax squared plus bx plus c. Now, this is not a calculator activity here. This is us. We got to do the work. Okay, this is algebra, is what this is. So this is the algebra part. And now we can verify if our two equations are the same with the calculator. We'll do that, but we got to be able to do the math to make it happen. Okay, so I'm going to take the original problem. Now, what does it, when we think about order of operations, if we're going to work this out and get it into standard form, order of operations tells me that I need to do the parentheses and exponents first. So the parentheses has the x minus 2. There's nothing I can do to that to combine it because they're not like terms. So the next step is the exponents. So the exponent is on the parenthesis. What does it mean to square x minus 2? Yeah, very good. X minus 2 times x minus 2. And then I still got the plus 5 out on the end. I got the negative 3 out in the front. Okay? Now, I'm going to still follow order of operations. After you do exponents, you multiply left to right. So I'm going to multiply these two things together first, and then I'll multiply that answer by negative 3. So x times x is x squared minus 2x minus another 2x, and then negative 2 times negative 2 is positive 4. And I still have the negative 3, and I still have the plus 5. I haven't done anything with them yet. I'm going to simplify that parenthesis, get x squared minus 4x plus 4. And then I still have the plus 5 out there. So I'm just simplifying. If you wanted to do that more than one step at a time, by all means do that. I'm just writing out every single step here so that we see where things are coming from. Okay? So I've taken and I've multiplied that out. Now I've simplified a little bit. Now I'm going to distribute and simplify one more time. So I'm going to distribute this negative 3 to everything on the inside of that parenthesis. So that's negative 3x squared plus 12x minus 12. Now I still have the plus 5 hanging out on the end down there. So I just did distributive property. Now the last step is put your like terms together. My like terms are that negative 12 and that plus 5. We'll have negative 3x squared plus 12x minus 7. And there's my standard form. Okay? Now, I told you we could use the calculator to verify that those two equations are the same. And you can. The first thing I'm going to do is graph the vertex form that they gave me. So I've got negative 3 parentheses x minus 2 squared plus 5. So there's that graph. Okay. If I graph the standard form and it is the same equation or the same parabola, what should it do? Match it. It should lay right on top of it, right? So I'm going to go to y equals, and I'm going to go to y2, and I'm going to type in that standard form that I found. Negative 3 x squared plus 12x minus 7. If this is the same one, that blue parabola that I drew earlier should turn red. It turned red. That's the same two equations. They match up perfectly. That means I did the math right. Okay. So I checked it, and those are two exact same parabolas, one in vertex form, one in standard form. Okay. So moving from vertex form to standard form takes the distributive property a whole lot and combining a lot of like terms. Okay. It takes the algebra that we already kind of been doing for a while. Okay. That's what going from vertex form to standard form is. To go the other direction, it takes the stuff we learned tonight. Okay. So let's look at the other direction of this. Kind of example D here. Write f of x equals 2x squared plus 8x plus 3 in vertex form. And just a reminder, vertex form, f of x, a x minus h squared plus k. All right. So I need h and k to get this to work. So I need the vertex of that standard form. How do I find the vertex of the standard form equation? Negative b over 2a is going to be the x value, and the y value is going to be plug that stuff in. So I'm going to do negative 8 divided by 2 times 2. That's going to give me the x value of my vertex. It's negative 8 over 4, which is negative 2. So my vertex is negative 2, and now I'm going to find the y value of that. So I'm going to take negative 2 and plug it in for x in that standard form problem. This is doing the algebra part to that. We could also use the graphing calculator to find this vertex, but I'm doing it by algebra right now. So that's going to be 2 times 4 minus 16 plus 3. That's 8 minus 16 plus 3. 8 minus 16 would be negative 8 plus 3 is negative 5. So the y value of the vertex is negative 5. That tells me h is negative 2 and k is negative 5. That's what that tells me. Those are the 2 of the 3 key pieces to vertex form. Vertex form, I need A, I need H, and I need K. Do I have A? What's A? 2. And I got that from the standard form because it's always the same. A is the same in standard form as it is in vertex form. Never changes. Okay? A is always the same. So if A is 2 in the standard form, A is going to be 2 in the vertex form. So now I have all of those pieces. So I'm going to take the negative 2 and I'm going to put it in place of the H. The negative 5 I'm going to put in place of the K. And the 2 I'm going to put in place of the A. So that is going to be f of x equals 2 parentheses x minus negative 2 squared plus negative 5. And I'm just going to clean that up a little bit because I got a double negative inside of the parentheses. So that'll clean up a little bit to be 2x plus 2 squared. And then I'm just going to write that as minus 5. And there we have our vertex form. And again, I can verify that by graphing the standard form and then graphing the vertex form on top of it. If it matches up, then I did it right. If it doesn't match, I did it wrong. Okay? So that's what I'm going to do next. I'm going to take the calculator. I'm going to graph the standard form, 2x squared plus 8x plus 3. Look at that graph first so you know what you're looking at. Okay, there's the original. Now I'm going to graph the vertex form. 2 parentheses x plus 2 close parentheses squared, minus 5. Covers it up, made it red. It's the same one. So that means I did it correctly. Kind of a good bit of stuff in this section, all quadratic based, but you have that verification with the graphing calculator that's always handy. Anytime you got the graph, I always tell my students when the final exam comes around for Math 100 or Math 110, if you don't know what else to do, graph the equation. You're going to find some stuff if you graph it. Same thing here. With quadratics, graph the equation. You're going to find some of the stuff if you graph it. That's going to help you, okay? So always remember, you can graph it to get you somewhere, okay? All right, so that's 3.1, the quadratic stuff, okay? So that's the last section that's just quadratic things, okay? Now, the next section really, I don't know if it necessarily fits here, but it's part of the standards for Math 100, so we're putting it here, and it's pretty easy. It's circles. So we're going to do circles next. Really not anywhere else to put it. Tonight's a good night to put circles in there. So we're going to do circles. 2.2, circles. All right. What you need to know about circles is the equation of a circle. And I guess it does kind of fit. The equation of a circle is x minus h squared plus y minus k squared equals r squared. Okay? So it looks a little bit like vertex form on a quadratic. So that's I guess that's kind of why it fits inside of this particular part of the course, as it looks a lot like vertex form. Okay? The center, so in geometry, the definition of a circle is all the points that are equidistant from a single point. So the center is that single point. The center is at the ordered pair HK. The radius is that distance they are away from that center point. And that's just going to be R. Okay. So we get this equation. So knowing this equation can get you the center and the radius of a circle. Or it can get you the equation of the circle if they give you the center and radius. And they're going to do both of those. So we're going to do a few examples of those. Not a ton, but a few examples of those. Okay? All right. So let's look at an equation that's got some numbers in it. Example A. Find the center and radius. Radius has an I in it. For x minus 5 squared plus y minus 3 squared equals 16. Okay. Using that form of the equation. The center, HK. Take the opposite sign. Remember on the parentheses, just like we did with vertex form, you're going to take the opposite sign. So if it's a minus 5, it's going to be positive 5. So 5, 3 would be the center. Okay. Now, this 16 down here is what r squared is. Okay, so to find the radius, we're going to take the square root of 16, which is 4. So we have the center and the radius now from the equation. And if we've got the center and the radius, we could draw the graph. We could go to this point and put a dot and then count out 4 to the right, 4 to the top, or to the north, 4 to the south, 4 to the east and west, and then kind of try to draw a circle. I don't think, some of you may be able to draw perfect circles. I cannot. Mine end up looking like squished up squares or flat basketballs or something. They don't end up looking out just right. Main thing is finding the center and the radius from the equation. Okay, let's do another one. Example B. Same thing. Find the center and radius for x plus 3 squared plus y minus 4 squared equals 49. And we're finding the center and the radius. Very good. -3, +4. Remember, take the opposite of the number in the parentheses. So opposite of +3 is a -3. Opposite of -4 is +4. Radius is going to be 7. Good job. The square root of 49 is where that's coming from, and that's 7. So that's the radius. Very good. Very, very easy stuff in this lesson. Okay. All right, let's see if we can do one more of those. Let's say we had a find the center and radius for y plus 7 squared plus x squared equals 12. I try to be tricky on this one. I'm just trying to get you exposure to the different types of things that you might see throughout your journeys with the circles. Callie. Very good, absolutely. That x squared is the same thing as x minus 0 squared. So yeah, the x value of the vertex would be 0. So on the center, or the vertex, the center, sorry, my brain was on quadratics. 0, -7, very good. And the radius, we got a 12 there. 12 is not a perfect square. I know that. So we got to break down that 12. So what multiplies to be 12? 6 and 2, and then 3 and 2, and there's a pair of 2s. So what's going to come outside? 2, and then 3 is going to stay in. So 2 radical 3 is the simplified version for the radius. Honestly, you could still get you could also get a decimal approximation for that if you wanted to, and then match it up with the one that is the same thing as that. So square root of 12 is the same thing as 2 radical 3 as a decimal, but really this is how they're most likely going to have the answer written. But you can do decimal approximations and find the one that matches. That's also legal. So we'll go about 3.46 is what the radius is. If I were going to have to graph it, I would go to decimals because I can't eyeball 2 radical 3, but I can eyeball 3.46. It's almost 3.5 out of that. Okay, so given an equation, finding the center and the radius. That's the first thing. Next thing is going the other direction. Write the equation of a circle with center 6, 8 and radius 13. Okay. So go the opposite direction. Very good. 13 squared, which we're going to get that number, would be 169. And that would be your final answer there with the 169 in there. If you can do it one direction, be able to do it the other direction. Where it gets a little bit more difficult or a little more confusing for folks is when we do one where it's like this. They give you a center of negative 13, 0, and a radius of 2 radical 2. That's where folks kind of start getting squirrely with it. So what's the equation of the circle with that center and that radius? Not x. Y. Y minus 0, or you could just put y squared. Same thing. Either way. I think probably on the Canvas assignment, you're going to see y squared. You won't see y minus 0 out of that. But because that's 0 on the y value, it's just y squared. And then we're squaring 2 radical 2. Okay? Don't let that get you nervous. Just put it in parentheses, 2 square root of 2, and then close the parentheses squared, and it's going to be 8. So we got x plus 13 squared plus y squared equals 8. Boom. Okay. One more. Center, negative 4, negative 5, with a diameter of 14. A little what they call general knowledge here that they expect you to know, even though it's not something that you would have learned in this course. What do we know about a diameter of a circle? You know, it's not, that would be circumference. Diameter would be, it would be two of the radius, right, all the way across. So it's the radius twice. So to find the radius, we're going to take that and divide it by 2. So that would be my radius. So if they give you diameter, you got to know I got to divide that by 2 to get my radius. So then my equation would be what? 49. 7 squared would be 49. Yeah, you can go ahead and do that in one step if you want to. So that ain't too bad. I mean, really, that's about as hard as they get in this particular section. This is, like I said, it's a pretty easy section. It seems to fit along with the vertex form because you got that parentheses squared stuff happening in there. It's the same idea with that. So that's why it's kind of in here. Okay. All right. We need a break. All right. Let's take a short break and let everybody get a drink.